All right, let's get started on our warm up
I
here.
like that one.
So, eeny, meeny, miny. I'm gonna pick somebody random to start us off. Dancing star. We had 3 pieces on this that we got to do. Give me one of the pieces we're gonna have to do. Yep, you picked kind of the sneaky one. All right, we got the number 4, we got the number 2 in here. They're just regular numbers. They don't have exponents, so we're just gonna divide them out. 4 divided by 2 is 2. All right, we got a couple more pieces on this thing.
Nope.
Ira, give me another piece of this problem we're gonna have to do.
Okay, x or -2 minus plus 5.
Because it's minus -5, right?
Yeah.
Which is really plus. So what do we get for our y's when I do -2 plus 5?
Yeah, 3.
We are y to the 3? Yep. All right, and then the last piece of this one. For our last piece, Victoria, we got our x's. How do we find those x's? Or x to the what power, I guess I should say.
X6 minus X3.
Yep.
X3.
And we get x to the 3. And then the only thing that I would do a little differently is I would put our variables in alphabetical order. This isn't wrong, but it's more correct to go 2, x to the 3rd, y to the 3rd. That is the most correct way to do this.
Most correct.
So if you did y first, you wouldn't be wrong. If you typed it in Socrative, it would say wrong because I typed in my x first. But as long as you have both those and the right exponents, don't worry about it. I need hoods off, headphones out.
Your head's on.
Whoa.
Just kidding.
Oh, okay.
Yeah, they're trying to be sneaky.
Jesus, really?
I know.
Goddamn. Look at this
Lethal Lily over here.
All right, so this is going to be our last
Lily, you
lesson
done.
in
Go
this chapter. And we're going to do a few different things. So to start with, we're going to look at we're going to be looking at exponential functions. We're going to be doing a little bit of graphing today and some other stuff.
I haven't played
So an exponential function usually looks like, it can look a little different, but it is y equals a times b to the x, where a and b are real numbers. So y equals a times b to the x. That is my exponential function. Remember, you guys should be taking notes because these notes are worth points.
I don't know any
Those fingers in that notebook. There you go.
Oh, this hurts.
Alright, so we're going to look at y equals a times b to the x, and we're going to graph these. Eventually, we're going to look at is something exponential or not. So these are just some examples of exponential functions. I have y equals 2x, y equals -2 to the x, to the x power. What makes exponential functions special is that my exponent is the variable x. That's what makes them special. And when we look at exponential functions, they all kind of look the same. We just might flip it around. Exponential functions always start off really, really slow, and then all of a sudden they jump way up. Kind of like I don't know, maybe like part of a mountain or something. They start off really slow and then jump way up. So that's what this one looks like. This blue one right here just got flipped upside down, so it starts off slow, then goes way down. And then these ones got flipped left and right was all. They got flipped left and right. But it's still the same basic shape. Starts off really slow, it just goes left, and then all of a sudden goes way up. Same thing here. Starts off really slow, and then just goes way down. That's how exponentials look like. They start off slow, and then all of a sudden they pick up speed really, really quick.
Why is that?
Because exponents get really big really fast.
Okay. Why though?
Why?
Because, okay, well, let's look at something.
Just do it. Okay, I was kidding. I didn't
Like
want
what,
you-
Goki?
I didn't want you to get further.
Yeah. That's what you get for asking questions, being curious.
Exponential growth, isn't it? Hey
Yes.
man, curiosity killed the cat.
Yeah, good thing you're people. Alright, so we're going to look at this table right here. I have an x and y row in my table. And I want to say, does this represent an exponential function?
No.
Well, we're going to find out.
No.
So I need 2 things for exponential. My x needs to change by the same amount, but as a plus or minus. If this is going to be exponential, my x's need to change by the same plus or minus amount. So let's look at my x's here. If I'm going from 0 to 1, how much am I plus or minusing?
1.
1.
Plus 1, right? Oh, come on. Plus 1. How about from 1 to 2?
1.
Plus 1.
Plus 1. 2 to 3.
And what?
Okay. So,
You just need.
my first part for this to be exponential is I am adding 1 to my x's, which is good. That's what I want. So, and this is what's going to usually change the most. To be exponential, my y's also must change by the same amount, but it's got to be a multiplier divide. So, when it's exponential, it's plus or minus for my x's. When it's exponential, it's multiply or divide for my
Multiply by
y's.
3.
So let's go
By
through it.
negative 3.
To go
I
from
know
1 to
my
3, what am I multiplying by?
3.
Just
Three.
not negative 3,
Just 3.
just 3. How about from 3 to 9, what do I multiply by?
Three.
Regular 3.
Regular
Yes, goal key.
How about from 9 to 27?
3.
Regular 3.
Regular.
Alright. Do my x's change by the same plus amount?
Yes.
Plus 1, plus 1, plus 1? Do my y's change by the same times amount? So this is exponential. I'm going to say yes.
No.
Exponential.
Wait, so are we just saying yes and no today for homework?
For the first part.
Ah.
And I'm going to abbreviate this exponential as EXP.
It's gonna be on paper?
Was exponential worse for
Right.
Spanish?
Okay, you said you were recording it. Did you mean like just saw that? Or, like,
End of sound.
So that's picking up everything we say.
Yes, it is.
Holy
Is it
shit.
easy?
Oh, first referral. Give me a referral. I'm going to put it on YouTube. It's going to go viral. Everybody's going to know.
Oh, everyone's like,
Savage.
savage.
Alright,
Oh,
we're going to look at a couple more of these, and we're going to see, are they
I wanna.
exponential, yes or no? So, let's look at my x's up top here. What are my x's changed by each time? They're all plus 1. That part's pretty easy. All my x's are plus 1. Let's look at my y's, though. If I'm going from negative 1 to 1, what am I multiplying by? Or dividing?
Regular 2.
That's adding. Multiplying, though.
No.
I'm
Negative 1.
multiplying by negative 1 to go from here to here, right? How about from 1 to 3, what am I multiplying by?
Times 3.
Are these the same numbers?
No.
So I don't need to do anything else. All I need to say is
No.
not exponential.
Nada.
And I'm going to just
Hey,
go
is that on the
EXP
Oh no.
for exponential. So as soon as I find one thing that's different, I don't need to keep going. And if it says explain, like on this last problem right here, it says explain. This math I did right here counts as explaining, or I will count it as explaining. So on this problem, if it says explain or something like this, and you do these things, that's all you need to explain.
Isn't that right?
That is right.
Alright, first in class problem, I want you to look at part B right here, and I want you to tell me, is it exponential, yes or no?
Yes.
Yeah, maybe.
Well,
It was so obvious.
I already did.
Gotta go
we did a homework now. What?
No, because we're gonna graph it. The times y's and the plus y's.
See, exponential.
I'll give you 30 seconds. I'm gonna go over it.
Hey, Cookie, you have a couple, bobby pins or something?
No, man.
Paper clip.
No, man.
I have a bobby pin.
Don't do it. You probably could get through that door. It's not very good.
Oh, I know I could.
It's on my coat.
I just need a paper clip too, though. I can't do it out of one. I learned how to do it out of 2.
1, 2, 3, 4.
Alright. Let's go over this first one. Who did I start with?
Yeah. Tyler.
We'll start with Caleb. Caleb, what are my x's changing by on top here?
1.
Are they all changing by 1?
Yes.
Yeah. They're all plus 1, right? Okay, let's keep going through quadri. If I'm going from 2 to 4, what am I changing by?
2.
Wait, mine's
Times 2. DeAndre, if I'm going from 4 to 8, what am I changing by?
2.
Times 2. Ryan, if I'm going from 8 to 16, what am I changing by?
10.
2.
Yep, times 2. Times 2, times 2, times 2. Hey, take your headphones off. We're doing our lesson. You listen later. Alright. So, Jake, are all these the same?
Yeah.
Yep, which means it's exponential. So I'm going to go yes, and I'm going to abbreviate it for exponential.
How come it says, how come it's Day of the Dead, but it's multiple days?
Dia de los Muertos?
It's the end of it, I think.
That's,
Dia
no, that's
de los
tomorrow.
Muertos.
I don't know. I don't know. I'm not Hispanic. I couldn't tell you.
Yeah, but you speak.
No, Hispanic.
Yeah, that's
Alright, so we're going to start getting into the main part of our lesson today. That was kind of an easy first part. So we are going to be making a table, and we're going to be graphing some exponential functions. So make sure you are on your Chromebook, and we are going to need Desmos today. So grab Desmos real quick, and I actually got to get Desmos going on my computer too. Give me a second. Yeah, man.
Isn't it?
Whoa, if you just spell Desmos, it'll bring you to the Desmos website.
On this side.
What?
For real.
What?
For real.
We should get those.
I get what?
Oh, I got it. Sticks.
Those rape sticks.
Oh.
That's what it looks like.
I don't know.
Oh,
Yeah. Deontay asked me to break them, and then I broke them, and then I put it on.
Okay, so we are going to be making a graph of this exponential function. But before we do that, we are going to be make a table. So we've done this before. Last year, you guys did this a lot. We haven't really done much this year, so kind of get you started. We are going to pick some x's, and then we are going to get some y's out of that, and then we are going to graph those points. So we're going to find the graph of y equals 3 times 2 to the x power. So I'm going to pick some x's, and we almost always pick the same x's.
Negative 1, 0, 1, 2, 3.
Yep. So we're going to pick x's, negative 1, 0, 1, 2, and 3.
For real.
Yep. There's a little bit more than we usually do today, but we're going to use Desmos, and it's going to be really easy.
For real, for real?
Yep. Because Desmos makes these really easy.
How easy?
Super easy.
Like 1 out of 10, how easy?
Like 2.
Do I really have 2 wins?
Okay. So, we're going to plug in these for our x's, and we actually could do this like normal. I could say I'm going to plug in negative 1 for my x. I'm going to go 3 times 2 to the negative 1, and I would get out my y. I plug just this line into Desmos and do that. But Desmos is nice. It is really good with tables, I think. Or pretty good with tables. So we're going to use that and make it easy. So, let me put it on my screen here
Can you use it?
so we can see it. There we go. Get my Desmos going here. Okay, so on Desmos now, make sure you guys are following along so you can see how to do it. We are going to insert or add an item. So go up here to your plus sign, click that, and go to table.
Go where?
So this plus sign up here,
Alright, so, never mind, I got it.
and then table. Plus sign, and then table. And it'll say like an x1 and then a y1. So before we go through and actually do our table here, we're going to have to do a couple of things real quick. So, the equation we are graphing is, let me just check it real quick. We are going to graph 3 times 2 to the x. I need to tell Desmos to graph that. So what I'm going to do is, you see where it says y1? Delete the y1. And we're going to type in 3 times 2, hit your exponent button, x, and then we have to add one more thing. Right now, just do 3 times 2 to the x. Let me actually zoom in a little bit here, make it easier to see. Since all we really need is our table right now.
How'd you do that?
Control and then mouse wheel up. I don't think there's okay, so real quick, you guys see how over here, this is x1 on this first part? We need to make our x an x1, just to tell Desmos it's a little different. So just type in a 1 afterwards.
Would it be a negative 1?
How do you put the? Oh wait, never mind.
So you're going to hit the button 3 times 2 exponent x1. So it should look like this.
Wait, what? Can you do
What
that
the
again?
heck?
Okay, I'll show you what. Okay, this first one says x1, right? Leave that one alone. This one, just to type it in again, we're doing 3 times 2 to the x. That is our equation we're doing.
Did you say
So-
something else after that?
3, just watch. 3
Okay, go ahead.
times 2 exponent button, which is this AB right here. Type in the variable x, and then type in the number 1. And it automatically goes down like that.
No, it doesn't. You're lying.
Yours doesn't?
No.
Mine does.
Oh, mine does.
Okay. Because Desmos is a little weird. When we do like a table, I need like an x1 or
No, I
something.
got it.
Okay. So, this is where Desmos gets pretty nice. So what was that first x we picked?
Negative 1.
Negative 1, right? I'm going to go down here under my x1. I'm going to type in -1. What happened right here?
Next, 12,
Yes.
It just filled in, right? I'm going to go here to my next one. I'm going to type in 0, and it fills in my answer. I'm going to go to my next one. I'm going to type in 1, 2, and then I said we're going to 3.
Yeah. You said 2.
We're going to 3.
Oh yeah.
What was that?
Times 3.
Oh yeah.
So,
Or no,
when
2.
we look at these,
Times 2. my bad.
Desmos is pretty nice because it did all the work for us on our table. I got 1.53, 6, 12, 24.
You put 4, you 48.
Yeah, and it just keeps going. We can put as many numbers here as we want. We could actually skip around if we wanted to. If I wanted to type in the number 10, I'd just type in 10 and get a big number.
Oh,
But
so-
we're not going to do all those. But I really like the tables on this just because it makes it really quick to fill them out.
Make me.
The only thing you got to remember, it's got to be that X and then you type the number 1 when we do tables. It's annoying, but you can deal with it. Okay, so I'm going to fill in this next part of my table. And this is going to go in the Y part on my table. So let me go back here real quick. Okay, so my Y's, I got 1.5, and then 3, and then 6, and then 12, and then 24. And we actually really aren't going to use this middle part of our table in this. Okay, we are going to have to actually graph it though. We are going to have to actually graph it. So, what's my smallest x and what's my biggest x?
0.5.
That's why.
Oh.
What's my smallest x?
-1.
What's my biggest x?
1 and 3.
So what should I make my x's go by?
3.
Just ones is fine, right? Okay,
Wait, what are we doing?
we're going to graph this now. So, this is the table we found in Desmos, right?
Oh.
So we are just going to graph this. So we made the table in Desmos, now we're going to graph it. So my x's, -1, 0, 1, 2, 3, I can go by 1, so I'm just going to write them here real quick. -1, 0, 1, 2, 3. And my smallest y is 1.5. My biggest y is 24. What should I make my y's go by, you think?
Probably 3.
We can do 3s. Or how about 2s? Let's go by 2s, make it a little easier.
Why did you ask me that?
Because I just wanted to see what you got. By 3s, I guess, if you want. But I'm going to make my y's go by 2s each time. Because I don't want to go up 24 lines. So I'm going to go by 2s. So I got 2,
6, 9.
4, 6, 8, 10, 12.
Hey, but you exactly have enough for
14.
24 though. I counted it out.
Yeah,
Yeah,
so
but
did I.
do you really want to count up 24? Or
I already did, dude.
Already did.
Do it by ones then, fine. See if I care. I'm trying to make it easy. But no, I'm gonna complain about it.
Well, you told us this now after we already did it.
All these flavors.
It's the weekend, be happy.
It's not the weekend yet.
We
We still have like 5 hours of school.
So go keep
Anything
How hours is irrelevant.
What was that,
How
Victoria?
many are you going up there?
I went up by 2s each
Can we
time.
go bathroom?
To 24?
After lesson? Yes.
Go
that's
game. You
25.
think I'm happy to be here?
Yes, I am. Eager, ecstatic. Alright, so I've got my graph set up. I need to actually graph my points now. So I have -1, -1, 1.5. So I'm going to go left 1 up to 1.5, which is going to be about right there.
That's 1 though. That's
I
like
have
25 though.
0, 3,
Oh, yeah,
0,
yeah.
3. Remember, if you went by 1s, your graph is going to look a little different just because I went by 2s, so mine's going to be smaller. I have 1, 6. Go here to 1, 6. I have 2, 12. Over here to 2, go up to 12. And then I've got 3, 24.
Wait, what's going on?
24. So all I did was graph the points I found earlier. So, we found our table. We had an X, we found the Y,
Nope,
X
I don't
and
like
Y. So we're graphing our points. That's all we're doing.
How much are you paying us for this?
I ain't paying thousands of future dollars that you'll make because you're going to graduate from this class and get a high school diploma.
Then you're in taxes.
Okay.
And you're like,
Taxes.
oh, this is-
Wait, so you can just do it right now? Let me graduate right now?
After you finish. And we've got our dots, but what am I going to do with my dots?
Hey,
I
wait,
don't know.
All I got is this year, next year, and I'm done.
What was that, Lily?
Never mind.
What do we got to do? What did you say?
Never mind. I was talking to myself. Because it's
Right.
like,
What'd you say? Yeah, it is on Desmos.
If you fold a piece of paper 113 times,
Shush.
and it's
Some
bigger
weird
than
useless facts later.
useless. It's exponential growth. It's the
That's
same
true.
thing with a
That
piece
is
of paper.
exponential growth. That's good. I appreciate that. Oh, shush.
Oh,
Alright, I got my dots. I just have to connect my dots now. That's all I got left. And remember, exponential, it starts off really slow and then it goes way up. So I'm going to start off really slow and then I'm going to go way up.
All the way up.
So my exponential function, when I graph it, it's going to look about like this.
Nothing can stop.
So finish this graph off if you haven't got it yet. We're going to do a couple more, and I think that's all we're going to do today. We might skip the last one, just because I want to.
No, it doesn't just be done now.
Can I do it? Can I do this?
Can I do?
I already asked you.
Caribou.
Can we just get the
What?
Caribou.
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 Whatever.
I got that.
That's where Poppy gets.
Oh no, I said can we just do the homework now?
No, we're going to do at least one more graphic one.
It's
All right,
Oh,
so
good.
we're going to do part A right here.
It's like you like wasting.
We're going to do part A. No, we're practicing. We're not wasting, we're practicing.
Oh,
So I have y equals 0.5 times 3 to the x. So just like before, I'm actually just going to write it right here. Times 3 to the x. So we are going to make a table, and then we are going to graph this. So what were the 4 or 5 points we're using?
-1, 0, 1, 2, 3.
Thanks, Lily. That's some good enthusiasm. -1, 0, 1, 2, 3.
And
Are we on a new one?
We're going to graph part A up here. So it's 0.5 times 3 to the x. So let me just grab Desmos again real quick.
he's your handy friend.
And it's actually pretty nice because
You just gotta do that side.
I only need to change this piece right here. I already have this left side of my table set up. I just need to change this piece.
Oh.
And it was, what did I say that equation was?
Time.
0.5 times 3 to the x. So I'm going to go through. I am going to delete my last problem. Just that little piece though. Just this piece on top right here.
Do we have to put the one after again?
Yeah, that's what it is.
Yes. Whenever you do a table, you always have to put the 1 after the x. It's kind of annoying, but... So I'm going to go 0.5 times 3 exponent button x, and then after that x, I got to type in the 1. So 0.5 times 3 to the x1.
Wow.
But it's really nice because
I'm confused. Go. No, not on that. I'm just never mind.
Okay.
Go ahead.
this is really nice because after I type that all in, everything shows up. I just need to put in stuff for my table now. So 0.16, 0.5, 1.5, 4.5, 13.5.
You're allowed to make the graph this way.
Do we have to write them all down in the box
Oh, that's
too?
dumb.
In the table?
Okay.
Yeah, you gotta make your table. But I should have actually changed this because on our tables, we're not really using this middle part right here. That was back when we used our different calculators and we needed to do extra work. So we're actually gonna skip the middle. We just need this part and this part. The x and the y. So, I used Desmos. I got 0.16 when I plugged in -1. Then I got 0.5. And then I got 1.5.
It's the same thing but backwards.
4.5 and 13. Or was it 13.5? 13. Okay, so just like before, we are going to graph these. So let's look at my y's. What's my smallest y is 0.16. My biggest y is 13.5. What should I make my y's go by?
Millions.
No.
2.
That's
Do
too
I
big.
have to?
We could do 2's or we could do 1's. 13.5 isn't very big, so I'm just going to go by 1's. And when you go by 1's, you don't have to actually write the numbers. Only when you go by something other than 1. So I'm going to go -1 for my x, 0.16 for my y. I'm just graphing this table here. I'm just going to kind of estimate where that is, because I can't see it exactly. It's going to be about right there. That's good enough. Then I have 0.5. Left and right 0 up to 0.5, about right there. I got 1, 1.5. That's about right there. 2, 4.5, 2, 1, 2, 3, 4.5. That's right there. Then I got 3, 13.5. 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no. Didn't have my 2s. I'm gonna estimate it's about right there. Yeah, I didn't make my graph big enough. Oh well. It's close enough.
Can I go bathroom now?
Not done with the lesson yet.
Oh
I thought you said we'd do one more. Who does?
Well, you got your exit ticket still.
Come on, Glocky.
Exit ticket's hard.
We're not doing that.
Oh, for real? Come on.
Mr. Glocky.
I'm almost done with it.
Okay, and then I got one last thing. I have to connect my dots.
Alright, next
Dots,
one.
dots,
I can't do it.
Yeah, good enough. Alright. So, I am going to make the lesson a little shorter because I want you guys to practice making your tables and your graphs. We're going to make part B here is going to be your exit ticket.
Oh,
Oh, I was already doing the exit ticket.
I know, right?
Wait, Mr. Bulky.
There's only a difference, it's just negative. Glocky. Where can we grab it at?
Just anywhere you have space, like on this one. They won't overlap.
Glocky.
So,
Mr. Bulky, can I just do the exit ticket? I'm almost done anyways.
Yeah, come on.
Like with this one, not that one. This one. Why?
that's not even your exit ticket. It's not on there.
Oh.
That was another in-class problem.
Glocky, you can't go home.
No. You gotta stay here for
The internet broke it.
Can I just erase?
That's fine.
The internet
Okay,
broke it.
so your exit ticket, just do part B. I will put your homework on Google Classroom in just a minute.
The internet's broken.
It is not
It's
broken.
not broken, Taylor. Are you done?
It may not be working well, but it's still good.
It might have been,